I mean, whether there's more than one or not, that should say are. Statements is plural, so.
Yeah, I think it should just be one, but I guess.
Well, I'm wondering if they're saying that. They're accidentally giving away the fact that there's only one. So let's just go through it.
The statement that would be true is E.
Let's go through them one by one.
Okay.
Okay. Is F decreasing between -1 and 1?
-1 and 1, no.
No, because it's got to be positive. Or, excuse me, it's got to be negative for it to be decreasing. And it's clearly positive from -1 to 0. Is F increasing from -2 to 0?
No.
Remember what it takes for F to be increasing.
Right, it's got to be positive.
Well, all of that's positive.
Yeah. Then yes, sorry, I thought it was -2 to 2.
It's tricky in having to almost think backwards is what you're really having to do here. So, yes, that's true. Is F increasing from 1 to 2?
1 to 2, no.
Does F have a local minimum at x equals 0?
No, it has a maximum.
Very good. Here I thought I was going to have to go through the explanation. At a local minimum, you go from negative slopes to positive slopes.
Right.
At local maximums, you go from positive slopes to negative slopes. And that's what that is doing, is it's going from positive to negative. Now, the last one. F prime is clearly not differentiable at that point and that point, which are corners or cusps. But that doesn't mean F isn't. And in fact, if it's not differentiable at those two values, what are we doing looking at its derivative?
Right.
So in order to get that, F had to be differentiable in the domain from -2 to 2.
Right.
Otherwise, we would have nothing there. If it wasn't differentiable at -1, we wouldn't have a value for its derivative.
Right.
All right. So what do we need to do here? Here they're not even talking about the derivative. Well, maybe they are. What do you think?
Well, usually when we find if it's increasing or not, that is when the slope is positive. That's when it's increasing. So we'll find what derivative is positive.
Okay, so we need to find where the derivative is positive. So what's the derivative?
300 minus 2x squared. Or 3x squared.
Okay, and this gets mildly tricky. Here, let me start up the top here. That's what we're going to try to solve, right?
Right.
Factor that left term, which you need to do.
So, we would pull out a 3. So 3 times 100 minus x squared greater than 0.
Okay. Which means 100 minus x squared has to be greater than 0.
Right, because the 3, it goes away.
Divide both sides by 3.
Right.
Okay, to get rid of it. Now, this is also a little tricky. What should we do here? I mean, you can look at this conceptually and figure out that x has to be less than plus or minus 100. Has to be less than 100 or greater than minus, I meant 10.
Yeah. Well, you could just solve it and you get negative x squared is greater than negative 100, and then divide by the negative. And then it's x squared equals greater than 100, and then you take the square root, and then it's plus or minus 10.
Yeah, that's the tricky part. In other words, you can't just say this. You do have to include the plus or minus. Because when x is negative, this is going to change the direction of that sign.
Correct.
Okay? And in fact, I need to do that. I did not do that. That's not the correct answer. The correct answer is this. See why?
I do not.
Well, if we took the original, what we had there, can x be 11 for this to be true?
No.
Okay, so we got to be on the other side of 10. We got to have it be less than plus 10 or greater. In fact, I need to write this in two different ways. Here's the solution. That's why I say this is a little tricky. Has to be greater than minus 10 and less than plus 10. So what's the right way to write that? A has to be greater than minus 10 and less than 10, and it's am I missing something here?
That is an answer. It's B.
Well, it's not really B. They use brackets, which means that it should be this.
Right.
The fact of the matter is it can't be 10. 100 minus 10 squared is not greater than 0. It's equal to 0. So, can't use those, which seems to me that should be parentheses. In other words, at 10, the function is not increasing. Function
Right.
0. And, well, hold on a second. Let me think about that for a moment. I'll just graph this real quickly. 300x minus x cubed. And And the question is, where is that increasing? Okay.
Right.
Well, it's not increasing there.
Right.
And it's not increasing or decreasing there. In other words, wherever you have horizontal tangent lines, it's neither increasing nor decreasing. So I don't think it's proper to say that it's increasing from -10 to 10 inclusive, but with parentheses, it is.
Okay.
Okay. I don't think you can use the bracket. I'm not 1,000% sure, but I'm pretty sure. Yeah, I think that's a typo. And A, they use the brackets in A also. Only A is where it's decreasing.
Right.
But that's also incorrect to use the brackets. So I'm not quite sure whether that's a typo or whether I'm thinking about it incorrectly, but that's the way I've thought about it for 10 years now, is
Right.
that it's neither increasing nor decreasing when it's equal to that number.
Right.
But if you had to pick one of those answers, obviously B would be what I would pick, unless there was a none of the above, and then I'd have a problem. But okay. So again, they give us the derivative function, and they tell us it has exactly 2 zeros, which we can see. There's one right there and another one right over there. Hold on. The domain of G is the set of all real numbers, then G is decreasing on which of the following intervals? Again, possibility of more than one, I guess.
Right.
In fact, this answers the previous question. Is it decreasing on that interval?
From -2 to 2. No.
I don't think it is either. It's going from here to here, but as long as they've got the equal sign, they're including -2 and 2. And it's not decreasing at -2 or 2. So,
Right, but it's also increasing anyways.
no, we're looking for decreasing.
Right, but it's wrong because it's increasing because it's -3, -2, -1.
That would be decreasing. In other words, if the original function is decreasing, its derivative is negative.
Right. Sorry, I forgot that this is the derivative.
Okay. So,
be careful.
there's also another little clue in these answers. First of all, is it decreasing there?
From -1 to 1, yes.
Yeah, so it's definitely decreasing on that interval, but is it only on that interval? In other words, what they're asking you to do here is decide whether it's increasing at -2 or 2. I'm beginning to think you need to ask your teacher here.
Okay.
Because we've got two questions in a row that if you assume the previous question was not a typo, no, there's no way A can be the answer here. Because clearly B is correct without the only. In other words, take away that only, and B is definitely an interval, right?
Right.
So A can't possibly be the answer because it says -2 to 2 only, and here's another one that we know for sure it's decreasing on that interval.
Right.
So the word only makes A incorrect. And I would say that is correct, and it's the only one. In other words, certainly greater than -2. No, there's positive numbers over there. Greater than 2, there's positive numbers over there. Less than 2, there's positive numbers there. Those are all intervals that it's increasing. But in decreasing, it's only B, which means for sure that this is a typo. But I would still check with your teacher.
Okay,
I will. Parentheses next to those tens instead of brackets.
Okay.
Not like them to have too many typos on these things. Okay, let me go to my email and see if I got anything new in here. I do. I might not be doing this the most efficient way, but it's the one way I have figured out that works, where I can open these things with paint, and then I can rotate them or zoom in or do the things I need to do.
Right. It's probably the easiest way to...
Well, this is a rather laborious method, as you can see. I got to go through quite a few steps here. But at least I can do it. I wasn't able to do it for a few months. It was terrible. I couldn't figure out how to read stuff. Okay. So here we have to give a reason. Again, they give us F prime. You notice they haven't been giving us a whole lot of F's and asking us questions about F prime. It's always the other way around.
Okay.
What intervals is it decreasing?
From 1 to 4 and from 6.5 to 7.
Okay, and it's either 1 to 4 with parentheses or brackets. I say parentheses.
Okay, I will definitely ask that question.
Yeah, you need to get it cleared up, I think, because I'm not, I'm still a little slightly confused on it. Okay, at what x values does f of x have a relative minimum?
So we're going from negative to positive. So that would be at x equals 4.
Okay. And on what intervals is f of x concave down?
Concave down. Isn't that where the double derivative is negative?
Yes.
So from -1 to 2 and 6 to 7?
Very good. Yeah. In other words, we know the second derivative is going to be negative because this is decreasing on that interval, and it's decreasing on that interval. So it tells us the second derivative is negative, and that's what you need to be concave down. And again, we kind of have a similar problem.
Okay. With the parentheses.
Whether it's parentheses or brackets, yeah.
Okay.
That's really critical because all of these you have to give an interval notation, I imagine.
Oh, yeah.
So you need to know whether it's parentheses or bracket. You could end up missing them all if you go the wrong way.
Right.
And at what point does the original function have a point of inflection?
I am not sure on that one.
That is where the second derivative is 0.
Okay, so
that's what separates concave up from concave down. If I have a function that looks like that, this part of it, hold on. Well, no, I guess I can draw in here. from here to there is concave up.
Right.
From here to somewhere up there, it's concave down. And the point in between is what the inflection point means. And
Okay.
the second derivative needs to be 0. Well, where is the second derivative 0 on this chart? In other words, this is the first derivative.
Mm-hmm.
Where's the second derivative 0?
2 and 6.
Yeah. Actually, I think I got the definition slightly wrong. It's where the second derivative is 0 or not defined.
So
Our second derivative is not defined at 2. That is a corner. We can't take the derivative at that point.
Right.
So we can't say the slope of the tangent line is 0. I cannot make that statement, either there or there.
Okay. So,
yeah, I think the definition is truly the inflection point is where it's either 0 or not defined.
Okay.
So these would be inflection points.
Okay.
I think, yeah. And notice why. No, the slope of the tangent line is defined there. It's just infinite. It has an infinite slope. So what would that look like on a first derivative? It would be a asymptotic. There would be a vertical asymptote, and it would go to infinity. Look at that question again. On what intervals? Oh no. Does it have an inflection point? I would still go with that answer. Again, less sure on this one than I was on the other one.
Okay.
I'm pretty sure the inflection point is where the second derivative is 0 or undefined, and in this case it's undefined.
Okay.
Okay. All right.
Should we save the next page for next time? And
yeah, I didn't realize we were close to. Glad you mentioned it. Actually, I'm playing bridge today, so I got things I got to do. I will talk to you next time, John, which is tomorrow.
I think I need to schedule some.
Yeah, you don't have one tomorrow.
Yeah.
I'll talk to you next time.
Okay. Thank you.
You're welcome. Bye-bye.
Bye.